Hello everyone, this is CTEC 102, Problem Solving and Programming Techniques. My name is Vladimir Chaynikov, you can call me Vlad. I'm an instructor for this class and I have an office, G123. However, this is an online class and I don't have any in-person classes, so I will not be in my office regularly. If you really want to see me in my office, message me, inbox me through the Canvas inboxes. In general, our office hours, for office hours, just inbox me and we can set up a Teams meeting. I will show you the where the link is for Teams meeting. Here it is, Teams meeting room, office hours, and there should be a link here. Not gonna click on it. So this is a summer class. This is an 8-week class, and compared to the regular classes that are 16 weeks old, this is my first time teaching an 8-week class, so this class is a little bit compressed. We are going to basically do 2 weeks of regular, say, fall semester classes in 1 week. So if you have taken this class earlier, be aware that we are moving faster and you will need to pay close attention to this class. Now definitely check out the syllabus and look at the modules. One thing that, well, you will find my video, the current video there, and new videos in my YouTube channel. Please subscribe to that channel so that you know when the new videos come out. And I will store all programs that I will use for this class in this public folder. You might have to get a permission for me to access it first time around. I'm not sure if you actually do, but in any case, this is where all the programs will be that I cover in my lectures, for example, and maybe some other programs. In fact, I'm actually contemplating leaving this Spring folder as just extra information. Alright, for every week, for every new chapter, I will have new lecture videos. Those will be long videos. It's not like itty-bitty 5-10 minute videos. My goal is to recreate the atmosphere of the regular classroom as much as I can. And I do expect you to watch those videos on your computer, not a phone, because on a phone you would be barely able to see what I'm talking about or call them. Now, all too often in this class, I will say the word Python, we will talk about Python, but you should not forget that this is about problem solving and programming techniques. The goal of this class is not to learn Python as much as to explain to you what is programming and to get you to do some simple programming tasks. This is definitely an introductory level class, and if you have previous experience with Python, you may find yourself in position where some of the things we're doing are very easy. And I did see students who stopped really following the class daily and then found out that it actually turned out to be more difficult than they thought. So if you have prior Python experience, first few weeks should not confuse you. Things will get more challenging as we go on. So keep close attention. Be sure to check all the materials. And for now, we have some general learner support. We have Teams meeting room, course information. And week 1, over here, in week 1 lecture and notes, there will be a lecture. There will be some extra videos. In general, there will be additional information, and there will be slides that I'm going to use for my lectures, and you can download and look at them by yourself. Now, this class comes with the book. Let me go back to the where the book information is. I think it is actually in syllabus. So here is our book information. The book is required, and moreover, you're not just required to watch every video that I'm posting. In fact, watching videos often does not do enough for you. Let's put it mildly, it's not enough to just watch videos, just like if you were to learn a sport, it's not enough to watch videos where they show you how to do this. And so get the book. It's a required weekly reading. You need to read through the chapter, you need to look at some examples, you need to actually code some examples, and also watch my video. In general, I think if this would be an in-person class, we would have 6 hours a week meeting in a classroom, plus time to do homework, which I would say as much or more per week. So this would be your normal time requirement for this class. Now here is I have 2 weeks planned out currently, and feel free to start. There are some due dates already that you can see either on the home page or on the in the modules as well, for example. So before completing each of this, definitely read the book, watch my videos, chapter 2 videos and such, and first of all, participate in the discussion. The format for discussions will be different. Some of them will be just make a post, some of them will be make a post and also react to someone else's comment on it. So be sure to do that, even if you feel that this may be not enough points to bother. Yes, those points add up. Do not look down on any of this assignment, because they are not enough points. Second thing to do is to complete a quiz. You can retake a quiz as many times as you want. The reason for the quiz is for you to have a chance to look through the material and to see how well you understand the material and review it once again. There will be some homeworks to submit, and when you do submit them, you submit a Python file. You submit a file, not a file that looks like this, which is how your code runs, but the code itself. If I want to run your code, I will run it myself, or I will just look through it. Often, especially if it is a complex project, I want to do both. So please don't send me this kind of thing. This is, by the way, for you to see how the code should look like. And I want to see a Python file. Please include your first name and last name in the name of the file that you are submitting. Alright, let's go back to the main page. So some important dates are here. Last date to drop. By the way, in order to not be marked as no-show, you need to complete one of these first assignments due June 7 in order to not be marked and automatically bumped out of this class as a no-show. So that's one of the things that you can read about in the syllabus. And the syllabus for this section is right here. Now, there will be programming assignments that will be a chunk of your grade. There will be discussions that will also add up to quite a bit of your grade. I talked about the quizzes previously. Since you can retake them, I basically take these quizzes as like an opportunity for you to get 100% easy. And midterm and final will not be much of the grade. They will be online and they will appear as the time for them comes. Final obviously will be during the final week. I may make it available a little earlier. course project will be a much bigger program than all the previous programs that you write, so you might want to start on it early, and I will emphasize it as soon as it comes to it. Since this is a summer class, I decided to do away with research paper and any kind of papers, and instead you will do a little bit more coding. Now, there is a separate video for you to know how to install IDLE, how to open IDLE, and how to do something with it. And please do check out that video. In case you are for any reason unable to install it, or don't want to install it, or you prefer another IDE, that's fine. If you have experience with another programming environment, that is absolutely up to you. You can make it work. So make it work by yourself and use it. If you want an online environment, you can sign up, for example, to Replit or Google Colab, and you will probably find and watch some videos, how to use it. If you like Replit more, that's okay too. I don't really care what environment you are using. The simplest one, especially for a beginner, would be just installing IDLE and using it. So if you are in doubt, use IDLE. Install Python and IDLE. Alright, so one more thing about grading. There are due dates over here. And also there are dates when these assignments will disappear. So you will not be able to assign them, to do them after the due date. Okay, maybe I should go to modules. So let me open this quiz. There is a due date June 7th, and there is also available date. You cannot submit them after the available. Now, if you submit them after the due date, there will be a penalty 4% per day, up to 40% penalty altogether. So please pay close attention to this class, to the assignments as they come up, and to the lectures and other information as it comes up. This is an 8-week class. It is a compressed class, so my recommendation is to work half an hour a day, because half an hour a day will serve you much better than, say, trying to do everything over a weekend, even if you end up spending more time on it. Yeah, half an hour a day is like a very bare naked minimum. If you have prior experience with Python, maybe it will help you. But in general, you should be spending more time on that. Okay. So how to work on this class, and what is the right mindset? Again, I cannot emphasize this enough. Even though we will talk about Python, Python is just a tool. So when you are driving a car, you don't think about say, the toolkit that you have in your trunk all the time. So Python is a toolkit for solving problems. The programming techniques we are going to discuss and the problem-solving skills that you are going to be working on, they don't depend on Python or another language that you are going to use. They are quite universal. Problem-solving skills are somewhat the same as they would be in for example, mathematics or in chemistry. Let me talk a little bit about that. So, problem-solving skills begin with understanding and knowing your tools. Knowing your tools means the material that we covered and the examples that you have seen and the general ideas you have seen. As they relate to this class. Second, problem-solving tools is You are reading the problem. It may sound silly to you, but it's not at all silly. You might want to read problem description 1, 2, 3, 4 times and give yourself time to relate these descriptions to your previous experience, to the tools that you know about, and your job as a problem solver is using these tools, combining these tools in order to solve the given problem. If the given problem is too hard, which you might find yourself thinking in later chapters, it's okay. You don't have to solve it right away. So I guess the strategy of doing something just before deadline, 2 hours before deadline, might be not the best one. So you might think about it. You might feel a little confused at first and then start to find your way around it. One of the important problem-solving skills, and probably this is the worst example to look at because it's a rather basic example, is forget some of the requirements. Modify your problem into something you can solve quickly and easily. And in general, in programming and problem solving, this is a very good, a very important technique. So this is a problem, for example, that will sound very intimidating to you when it comes to it, maybe to some of you. It's a long description, something with numbers and something scary. This is how the program is supposed to run, or similarly, and there is a list of things that you might need and hints, and you read this 1, 2, 3 times, and you might not be very comfortable with this. So you can first ease this problem, make it easier, forget some of the requirements, and I actually hint you how to start. Start with a simpler design and try to implement a simpler design and then build on it. If you perfect a simpler design, first of all, it will at least be a chunk of partial credit there, and second, it will give you ideas how to improve. An important principle about problem solving: create a prototype that works. If we're speaking about programming, whenever you are confused about the whole project, the whole problem, do something that works, that is relevant to your problem, and perfect it. And make sure it works, and then think how to extend it to the general scenario. Alright, and what not to do? What not to do? There are certain toxic techniques that people may have learned, especially over COVID. That is, taking a name of the assignment or some wording verbiage from the assignment and Googling it. So everything that happens after that, if you Google name of the assignment or some verbiage of the assignment and Python and so on, everything you see after that will be considered cheating. Now there are all these cheat resources such as Chegg and just the whole process of looking for the most similar problem to the current problem, and then people convince themselves that they understood it and they end up essentially copy-pasting it. Do not do that. So problem solving is not about Googling. You can Google technical stuff. For example, you can Google remainder in Python. And you can learn something from one of the 3 online code camp sources if that is what you want to do. And then you can figure out how to use it to that problem as it pertains to that problem. That is okay. That might not be the fastest way to solve a problem. So the book definitely has enough information for you to solve this problem. My lecture also, in my humble opinion, will have enough information for you to start solving a problem. So don't be scared about feeling confused and not knowing where to start. Think through the tools you have think which tool is needed, which tool, where do you want to start, and start from an easier prototype. Unfortunately, some people end up doing ton of Googling and really trying to use what they don't understand, and it might work 1, 2, 3, 4 times. I did see people crash and burn, so sometime in the middle of the semester, do not do that. And obviously, another thing not to do is do not share your code. Do not share your code with your classmates. And I guess that's it for the introduction.